Hi, welcome to our next session, which is on functions. Before we actually start understanding the concepts of functions, let's try and understand an application. Let's look at an application. Cricket is a very popular game in India, and nowadays T20 is really catching up. So let's try and look at an application of functions in T20. Suppose we go for a T20 cricket match and then we are told that the runs being scored by the batting team follows a certain pattern. So suppose you are told that in the first 5 overs, the runs scored in any one over is equal to square of that over number. So if we understand this, hence in the third over, the number of runs scored would be 3 square, which is 9. And this would be the pattern for the first 5 overs. Suppose when we look at over number 6 to 10 and we are told that the number of runs scored is equal to twice that particular over number. So if we look at over number 7, then the number of runs scored is 14, and this pattern is followed from over numbers 6 to 10. If we move beyond that to the next set of 5 overs and we look at over numbers 11 to 15, we are told that the number of runs scored in any one over is equal to the over number, and hence if I look at, let's say, over number 14, then the number of runs scored in that over is also 14. This pattern is maintained for 5 overs from over number 11 to over number 15. And then in the final set of 5 overs, the number of runs scored is a constant, which means every over 10 runs are scored. So whichever be the over, from 16 to 20, 10 runs are scored. And if we now track this entire run scoring pattern, we've been asked in the 20 overs how many runs have been scored. So if you want to now look at this kind of a problem, we first need to understand some basics of functions, and then we will come back, see how this kind of a problem can be represented in terms of functions, and then see how to solve it. So let's move on to some basic concepts of functions. Let's understand some few basic concepts of functions. Now, first of all, what is a function? Now, if we try and understand it in a very, very simple manner, function is some kind of an operation which would be performed on some input giving some particular output. So when we look at it in this manner, there is some kind of an input which is fed in, and depending on whatever is the function, the output would come out. So there could be different kinds of functions. Let's understand some very basic kinds of functions. So if I look at the first type, suppose I say identity function. The identity function basically means y as a function of x is equal to x. So what does this mean? The input is x, the output is y, and what the function here basically does is that whatever is the input, the same gets reproduced as the output. So this, to that extent, can be understood as a lazy function, because it really does nothing. It just takes the input and that itself is sent out as the output. So this is an identity function where fx is nothing but equal to x. There can be another kind of a function, suppose a constant function. Once again, when we say y is a function of x, suppose we say it is equal to a, where a is a constant. Now if identity was considered as a lazy function, then constant function is lazier than the identity function, because here the function really once again does nothing. Whatever be the value of x, the output, which is the value of y, remains the same every time. So here the output is independent of the value of x, which is the input. The output always remains the same. If we look at another kind of a function, suppose it is a modulus function, or it can also be called as the absolute value function. So if we say y as a function of x is equal to mod of x. Now what this function does is, it just takes the magnitude of the input, which is x. So if the magnitude of the input is 2, then the output is also 2. However, if the input is minus 2, if the input was 2, we've got the output as 2. If the input is minus 2, this function, because it's going to take only the absolute value, the output will still remain 2, and hence such a function will always give an output which is a non-negative value. Modulus function can never have the output as a negative value. So these are the different kinds of very basic functions that we've looked at, and if we now again relate it back to this, function is basically some kind of an operation performed on an input to give a certain output depending on whatever is the type of the function. Let's move on to yet another type of a function. Suppose we look at something called as a composite function. Now in very simple terms, a composite function can be defined as a function of a function. So if we go back to the way we had defined a function right in the beginning, we said there is a particular operation which is performed on some input to give some output. Now if a composite function is a function of a function, then for this input x, suppose the function is fx and hence the output is fx, then this output of the first function will go in as the input to the second function. So if we call this function 2 and if we call this function 1, and if this gives me some other output, actually it will not be gx, it will be g of fx, because fx was the input and based on that the output is g of fx. So there are two functions here, one function which is f, another function which is g, and when we look at a composite function, the way we treat this is input giving one output and that output being fed as the second input, and hence a composite function basically becomes a function of a function. Let's try and understand this with an example. Suppose we say there is a function fx which is equal to x square and there is a function gx which is equal to 2x plus 1. Now if we want to find g of fx, then what that means is in the function g, wherever there is x, replace fx, and fx itself is x square. So g of fx would mean we are finding g of x square. So in the function gx, which was defined as 2x plus 1, wherever there is x, we replace it by x square. So g of fx will become equal to 2x square plus 1. Similarly, we can find f of gx. Now gx is defined as 2x plus 1, so f of gx is nothing but f of 2x plus 1. So now what we would do is in the function fx, wherever there is x, we replace that x by 2x plus 1, and hence this would become 2x plus 1 the whole square. Now we've taken this only as g of fx or f of gx, but there could be several problems which could ask you to perform this operation several times. So you could be asked to find f of x. So all that we need to do is first find this and keep substituting that value that you found in the function fx repeatedly till you perform this the number of times that you've been asked to perform. So in very simple terms, once again, a composite function means a function of a function, and hence we just keep replacing depending on whatever is asked. Having now seen the concepts of functions, let's go back to the example that we looked at right in the beginning. We are talking about T20 and the run scoring pattern by the batting team. Now what we had discussed was that in the first 5 overs, the batting team follows a pattern such that the number of runs scored in any one over is equal to square of that over number. Now this can be represented as a function where we say fx is equal to x square when x is from 1 to 5. So in the first 5 overs, the number of runs scored would be equal to x square in each over. If we move on to the next set of 5 overs, which means overs from 6 to 10, then we had said that the number of runs scored would be double the over number, and hence now fx would be equal to 2x, where x is the over number and this is for the range 6 to 10. If we look at the third set, which means from over numbers 11 to 15, then the number of runs scored in any one over is equal to the over number, which means fx is equal to x. And finally, for the last 5 overs, which means from over 16 to 20, the number of runs scored is a constant and there are 10 runs scored in each over. And the question asked was, in the entire batting inning of 20 overs, how many runs were scored by this particular batting team? Now, this problem could have also been given in this form without getting into details the way we had discussed in the form of words. And we have seen a lot of students get scared when they look at something of this type, a functions problem expressed in this manner. All that it means is, if the value of x is from 1 to 5, this is what we consider. If it is from 6 to 10, this is what we consider, and so on. And hence now if we look at the total number of runs scored, then in the first 5 overs, we can find out the total number of runs scored as 1 plus 4 plus 9 plus 16 plus 25. In the next set, we will have the number of runs scored as 2 times, if I can take 2 common, 6 plus 7 plus 8 plus 9 plus 10. And then in the next set of 5 overs, the number of runs scored would be 11 plus 12 plus 13 plus 14 plus 15. And finally, you will have 10 being calculated 5 times. So 50 runs scored in the last 5 overs. So actually this problem gets reduced to a simple test of addition and nothing else. This is how we can actually make use of functions in our regular daily applications also. And instead of getting scared looking at this kind of a format of a question, if we just have the patience to calculate mechanically, these questions can become extremely simple.